So the previous sections, we have the quick sort using tree. And there's another variation. We have the quick sort using in place. So what does it mean by the in place? So this is the word. So in place means we have the rank L and R. L and R means the rank. Rank is a kind of position or indexing. So if the rank is L and R or in between L and R, then we will rearrange in the increasing order. So if L is higher than R, is so L, it will be always less than R. So I will be a random integer between L and R. And then we will select what is the element, the rank I. So it is X. And then we will do the in place partition. So in this case, we have X and K. So we will do the recursion. We will do the recursion. So the recursion will be from L until X minus 1, X and K. And then the in place will be from the K plus 1 until R. We call this is the in place because we do not need any storage, and we can perform like the partition using two indices to split S into L and E, which is the union of G. Okay, wait a moment. Why I put this here? Okay. So we have the same L, which is lower than the pivot, and we have G, which is higher than the pivot, less than pivot. And yeah, we can also have a similar way to split E union G. So we call this is union. So we just combine E and G into one. Or if you want to split E and G, that's also fine. Now let's suppose we have this data. Okay. We have 3, 2, 5, 1, 0, 7, 3, 5, 9, 2, 7, 9, 8, 9, 7, 6, 9. So your task is to sort this number. Using the quick sort, we need to choose a pivot. So let's choose 6. Okay. Let's choose 6 as the pivot. So we can repeat until J and K cross. So we can do each of this one until J and K across. It means we can send the J to the right until finding an element higher than X. So we start from J close to 1 and then go to the right. So is it higher than X? What is X? X is 6. Is it higher than X? No. Then go. Is it higher than X? No. 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 Is it higher than X? Yes. So we have this. And then after we have this one, we scan K to the left. So K from the left. And then left until finding an element which is less than X. So we set this one. This is less than 6. No. go here. Less than 6, no. 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 Less than 6, yes. Okay. So we have this value. Because we already have this is J and this is K. So we swap. So now it becomes 2 and it becomes 7 at this. Then we will do this repetition. So let's see an example. So we have the pivot is 50. So we have L and we have R at this stage. So we want to check whether from the left, we want to check if there is a value which is higher than the pivot, and from the R, we want to check whether there is a value which is lower than the pivot. So we start from index 1 and we start from the last before the pivot. And we check. This is higher than the pivot. Yes. This is lower than the pivot. Yes. So we swap. After that, we move L to this one and we move R to this one. Again, we check. This is higher than the pivot? No. This is lower than pivot? Yes. So we still moving. Okay. So we move this one because this is not higher than the pivot. So we move to next, this one, 63. And this one is lower than the pivot. Then we swap. After that, we already swapped 63 and 17. Now we go to this. Is this less than pivot? Yes. This is higher than the pivot? No. So because we already reached L equals to R, then we cannot split anymore. We cannot swap anymore. And we will check the next with this as the L and this is the R. And then we will check this one with the pivot. So is this a value higher than the pivot? Yes, because it is higher than the pivot, then swap. And we have this one. Again, we will start from the L and R from the beginning. So we will start again until it becomes sorted from the lower until the higher value. So this is the in-place quick sort. So we have S, we have A and B. So A and B means the element to be able to scan from the left and right. So if already A is higher than or equal to B, then just return. And then we have the pivot, which is the SV. This is the last element. And we will do the A from we will do from the left, and the right will be B minus 1. So if left is less than or equal to right, then we will do the scanning. Do the scanning. we saw left will be added by 1 if the left is less than the right, and then s left is less than by 1. If left less than the right and then the pivot is less than the s right, then right will be minus by 1. If the left is less than the right, then swap. Okay, so you already know how to swap this one. Right, left. So left will be left plus 1 and right will be right minus 1. So put pivot into its final place. So if you already mark with the left index, then you have the S left equals to SP and the SP equals to the S left. And yeah, we will do the in place quick sort. So we will begin to repetition. It is from the left, and after you finish, you can do from the right. And this is the recursion. So in overall, so you can get the result using the selection sort is O(n) power of 2, using the insertion sort is O(n) power of 2, using the quick sort O(n) log n. This is expected. Why? Why expected? Because if you choose the wrong pivot, what happened? If you choose the wrong pivot, it will be the worst case. And the worst case will be n power of. Okay. So we expect if we choose the good call. Okay. If we choose the good call or if we choose the good pivot, then yeah, we have n log n. But if we choose the bad call or the bad pivot, then in the worst case we will have n power of 2. Okay. For the hit sort, yeah, because I don't explain, it is n log n, and the merge sort, it is n log n. So you can see here, okay, one solution. Let's say this is I want to sort. Okay, so the sorting algorithm. So I want to do sorting. I want to do sorting with selection sort or insertion sort or quick sort or heap sort or merge sort. And then you will get the time. Okay, so the time is the complexity. So your project, your team project should do this analysis. So your team project should mention what is your algorithm and what is the complexity time. Because your team members mostly are 4 members, so it means you need to have at least 4 algorithms. 1, 2, 3, 4. So you need to show 4 algorithms. And yeah, I show you one example. So I give one Jupyter notebook. You can check on the e-class. Once you have your algorithm, so you can check how long it will take to solve your problem. So you already learned from the week number 3. So using this formula, we can get the running time. The running time means when we and then when we do the algorithm, and then when we finish the algorithm. So we want to check how long it will take to run the algorithm. Now let's use the merge sort. Okay, so this is the merge sort from the one that we learned in the class. Okay. So you can check the code. Okay. I will not explain again the code. So this is the same with the code in the PowerPoint. And then I want to check the time. Okay, let's say, yeah, I put an empty list. So let's suppose I have a sequence 5, 6, 3, 7, 2, 10, 7, 9, 12, 1, 13. And then I will do the runtime word sort with the S. S is this sequence. So I want to check what is the test time. So if you check this one, the test time, okay, 0.0. Because the data is very small, of course, we cannot see the time. Let's just put the A1 into the list. Now, I want to create a new data because with only 8 data, okay, sorry, 10 data, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, with 11 data, maybe it's very fast. But what if I want to create more data? So let's run this one. From the data, as I know that the mean or the average is 6.8. And I know that the standard deviation is 3.77. Then let me say that with the S equals to 10 data, now I want to generate another data. So I call it random generator. So the random generator, I would like to use the Gaussian values. Have you heard Gaussian values? Maybe you learn in the statistics about this one. So usually we use this as the distribution normal distribution, normal distribution. In the normal distribution, we have two parameters, which is mu and phi. This is referred to the mean and standard deviation. So I'm going to make a random data where the random data should follow with the Gaussian distribution or the normal distribution where the mu is 6.8 and the standard deviation is 3.76. So this is the data that I have before. This one 6.8 and 3.76. So using this one, then I can generate the new 10 data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there are 10 data. So I'm going to generate 10 data, and this is only the seed. The seed means if I run in my computer, and if I run this code in your computer, the result of random will be the same. If you do not use the seed, when I run this random generator in my computer, it will be different with your computer. So make sure that it is the same between my computer and your computer and set the seed. So random, this seed random generator is every number. Okay? It is in between 0 until 255. So let me just put 1. And then I use the seed and the Gaussian. So seed means the random for this computer, and then the Gaussian, I would like to generate 10 data with the Gaussian distribution. So using the same idea, I want to generate 100 data. Okay? I want to generate 100 data. The same with the previous one, I want to generate 1000 data. The same with the previous one, I want to generate 10,000 data. So it means it is random. So let's run. Suppose I have 100 data. So I'm using the S100 and I'm going to apply the merge sort. Then the runtime will be in this A100, and then I will put it into the test type. Maybe if you want to split this one, A100, if I run this, still 0.0 because 100 data is very small. And then I will put it into the test type. So I will also do the same with 1000 and 10,000 data. So if I put this one, okay, with 10 data, the computational time is 0. With 100 data, the computational time is 0. With 1000 data, the computational time is 0.01 second. With 10,000 data, the computational time is 0.05. Then it means with the higher data, you can see there is an increment on the time. So you can plot. So I show you the plot function like this one. Using the merge sort, so this is the time. Okay, this is the time when you increase the data. Now let's try to do with the quick sort. Okay, let me just use this quick sort. Okay, let me just use this quick sort and then I do the same. Okay, so I do the same with the data equals to 10, the data with 100 with 100 elements, 1000 elements, 10,000 elements. And then again, I can plot. So I plot this one, quick sort versus quick sort. So I'm going to put the test time, which is the red. Yeah, in this case, this is the test time is for the merge sort, and this is the test time Q sort is for the quick sort, and it will be blue color. So the legend means only the title, and then show. So by showing this one, I know that okay, the computational time of quick sort this is higher than the merge sort. So the merge sort is somehow better than quick sort because time, if it is higher, it means it is longer. So we want to get the same result, but faster. Now I have another sort. For example, I put another sort. This is bubble sort. So bubble sort, this is the code. Let's say, yeah, I just got this one. And then, yeah, you can also try to get the code from anywhere. And then I will try again the bubble sort with 10 data, 100 data, 1000 data, and 10,000 data. And then I'm going to plot again. So I'm going to check the comparison between merge sort, quick sort, and bubble sort. So the merge sort will be on the right, the quick sort will be on the blue, and the bubble sort will be on the green. Now you can see the merge sort is the lowest operational time, and then followed by the blue, which is quick sort, and the longest algorithm is bubble sort. Then what is your conclusion? Then the fastest algorithm for this data set is merge sort. And the longest algorithm for this data set is bubble sort. Okay. So your project, your team project should show this one. When you hit small data, of course, you may have difficulties. You have difficulties to make this graph. That's why you can generate random data. Okay, I teach you in this case. This is using random data. And when you do with the random data, you can show this graph. And then at the end, conclude. Okay. So the conclusion is also the same with this one. So you need to show the complexity and you need to show also the operation time. Okay. The operation time, you need to use the random generator. Any random generator will be fine. But I already teach you one random generator using sheet and Gaussian. So the next section we will learn about graph. Then we will look at random generator for graph. Okay. There will be another random generator for graph. Okay, so that's the thing about the sort. Any questions? No question, then I will continue with the next section. We are looking at the graph. So we are going to learn about graph and the terminologies and what is the graph ADT and then the implementation of the Python code. What is graph? A graph is a data structure. Okay. We have a data structure of graph, and this is a pair of V and E. We call it a set of nodes or vertices. E is a collection of pair of vertices. We call it edges. So vertices and edges are positions and store the elements. For example, this is a small example about a graph. SFO, ORD, LAX, DFW. So this is an example from the book. We have SFO, it is the San Francisco. LAX, it is Los Angeles. ORD is Chicago, O'Hare Airport. And DFW is Dallas. So let's say I want to fly from San Francisco to Chicago. So it will have like 1,843 miles, or this is the distance. From Chicago, I can fly to Dallas, and the distance is 802. I want to fly from San Francisco to Los Angeles. The distance is 347. And so on. So I want to fly from Los Angeles to O'Hare of Chicago, and the distance is 1,743. So because this is okay, this is no, and because this is X. So the example here, it represents that the vertex represent an airport and stores the three-letter airport code. So SFO is the three-letter of the airport. And in X represent a flight route between two airports and stores the mileage of the route. So from LAX to Honolulu, it's an up is Honolulu. From Los Angeles to Honolulu, it will give you 200 2,555 miles. In graph, we have several terminologies. We call directed at directed. Yeah. So we have the directed at, it means we have an order pair of vertices. Order pair. Order means sunsor. Where is the start and where is the end? So we call this is order pair. So we want to start from U and then we will go to V. In this case, I want to start from ORD and then I will finish at the PVV. So the first vertex U, we call it, this is the origin. We call this is origin. And the second vertex V, we call it destination. So this is the destination. Then if you have a trip from ORD to PVD, it means this is the origin and this is the destination. And this directed X means there is an information or maybe the flight information, or you have distance information and so on. So for example, a flight. This is directed X. But there's another type, we call it undirected X. Undirected. Yang opsi. So if there is no direction, it means it is only to see there is a connection between U and V. So unordered pair. So you go from ORD to PVD, it will be the same with the PVD to ORD. So this one and this one, so it has the same information, that is 849 times. So the flight route, can be represented as undirected X. We call directed graph. If we call directed graph means all the edges are directed. So if we have all with direction like this one, then this is directed graph. For example, the root network. If undirected graph, undirected graph means all the edges are undirected. So if you have like this one, if there is no direction, then it is undirected. So for example, the flat network, usually we say this is undirected graph. So there are many applications for this one. For example, the electronic circuits. Okay, if you are in electronics, I guess you need this kind of graph. Transportation network. So in our field, in industrial engineering, it is important to understand the transportation network. So most important, like this one, the soul subway. So you can, let's say, find the route. I want to start from Yongin. Maybe I will start from Everland and then I want to go to Gangnam. Then you will find the network. And the other kind of network, it is the flight network. Okay. For example, you want to go to Busan and you are now in Incheon. Then you will go to Gimpo to get the flight to Busan. Or if there is a flight from Incheon, you can go to Busan from Incheon. There's another kind of application. You can use computer networks, okay, like the Wi-Fi. It is also using some kind of network and database. Okay, you can use the graph to represent the entity relationship diagram. So some terminologies in the graph, we have several terminologies. We call n vertices. or endpoints of an edge. So U and V are the endpoints of A. So A, it is the edge. So U and V are the endpoint. Edge is incident on a vertex. So you see this one, A, D, and B. A, D, and B. It is the X incident on B. We have adjacent vertices. Adjacent vertices, U and V are adjacent. Now, let's see. V and X. This is also adjacent. Why? Because both of nodes, they have an S. Now, can I say U and Y adjacent? U and Y. Is it adjacent? This is not adjacent. Because if you want to go from U to Y, you need to pass by W and then go to Y. So it is not adjacent. Adjacent means it is directly connected with an edge. Degree of vertex. Degree of vertex means you have how many edges. So X has the degree of 5. 1, 2, 3, 4, 5. Parallel edges. So we have H and I, they are parallel edges. So H and I. We call it is parallel because H is an edge of X and Z. I is also an edge of X and Z. And self-loop. Self-loop means the X is from and going to the same vertex. So Z is no, and then J is upon an X from Z and go to its node. Okay. So we got this is self-loop. Okay, then maybe I will stop here. Okay, I will continue this Monday. Okay, so before we finish our class,